Hello, dual credit math instructors, and welcome to this brief video highlighting the benefits of using GeoGebra, the online graphing calculator. Some of the benefits of using GeoGebra? Well, it's free, no cost at all to the students. The graphics are great for illustrating math concepts, it's continually getting better, students have fun with it, and it integrates nicely with Smartboard. A few of the negatives. Well, it still requires some typing for advanced features. Because it's constantly getting better, you have to work to keep up with changes. And then there's still, for some features, there's some menus missing and needed that would be helpful. Additionally, GeoGebra is not always intuitive. It's overall user-friendly, but it does have exceptions, and it can have some lag as well. So let's get started. We'll begin with some basic operations. Since this is a calculator after all. First, we'll start with this example. Evaluate the expression for the given value. Go ahead and jot that down, and we'll give it a try. To evaluate our given rational expression at x equals -2, you can enter it in. Replacing x with -2. And get your result. Notice we obtain -11/23. If we wanted that in decimal form, we can hit the little approximation key and get a decimal approximation for that. And to go back, just click it again. For our next example, we can evaluate this given function for x equals -2, and then we'll use the quadratic formula to find the roots of the function. Notice it says no cheating with the graph yet. That's because GeoGebra makes it very easy to find those roots, but we'll show you both ways. So before we enter our new function, it's worth noting that anytime you begin a new problem, it's good to clear out your old information, and you can do that quickly by going up to the 3-bar menu in the top left corner, main menu. Under File, click on New, and then click on Don't Save, and it will erase any input that you had there before and give you a fresh start with less problems. So now we can enter 5x squared minus 2x minus 3, and hit enter, and notice it will give you the f of x notation for your function that you just entered. Notice it does also give you the graph of the function. If we want to evaluate this function for x equals -2, we can just type in f of -2 and hit enter, and there's our value. So in addition to calculating function values, we can also use GeoGebra to type in the quadratic formula for a given function to find the values of the roots. So to save time, I've already got that entered. So I split them up, and if you notice the keyboard at the bottom of the screen, you can click on that, and that'll give you additional tools that you can type in, and that's where you'll locate the square root symbol. But notice, so we've got our -b plus the square root expression here, and -b minus here. So our roots are +1 and -3/5. And if you go to the graph and you click on the curve, you'll see those roots pop up for you. So it's pretty handy. Okay, so next we'll use GeoGebra to evaluate some radical expressions. So take a minute to jot these down. Square root of 576 and fifth root of -121. Okay, for our radical expressions, like I mentioned before, you can use the little keyboard tool at the bottom. And for the square root of 576, we can use the square root key, type in 576, and hit enter and get a quick solution. Then for the fifth root, if you go down to the menu on the keyboard and click on f of x, there is a radical key that will let you enter different roots. So here we can specify the fifth root of negative 121, and there you go. So some other functions we can enter on GeoGebra and get quick results for are logarithmic functions and also trigonometric functions. So jot each of these down real quick, and then we'll try those on GeoGebra as well. Okay, so again, use your keyboard tool at the bottom, and we'll go to f of x, and we can use the log key. And it's giving us the option to change the base, so we'll make it log base 4 and of 5. Works pretty quickly. Then we can do some trig functions. Sine 45 degrees. GeoGebra will automatically read 45 in terms of degrees. And then for tangent pi over 6, it should also automatically read pi over 6 and answer in radians. If you do want to adjust that, you can go to the far right over to the settings tool, and under settings, if we go to the bottom curve, this gives us the algebra options, and you'll notice the last choice on the menu is angle unit. It's in degrees. You can change it with the drop down box, so that's pretty handy if you want to use that. And as the title reads, everybody's favorite, converting from decimal to a fraction. So to convert from a decimal to a fraction, you can start typing in the word fraction, and we're going to choose fraction text number, and we'll enter 0.825 and hit enter, and there's our fraction conversion. Same thing for the next 3.14. Start typing in fraction text, and there you go. You'll find that for many tools, if you start to type in the word, it will pull up the list of all the options, and usually you can find what you want to do. Not always, but usually. Okay, moving on. Now we can get into some basic graphing and some more fun stuff. So first, jot these 3 points down real quick, and we'll start with basically graphing points. So a couple basic notes about the graph before we start plotting the points. You can click onto any part of the blank graph and click and drag it to move the origin around, however you prefer. You can zoom in and zoom out with the zoom in and zoom out keys down below. You can also use the mouse wheel to zoom in and zoom out. There's also select the gear at the top, the settings gear that we've looked at before, and go to settings. And you can adjust the X-min, X-max, Y-min, Y-max. You can play around with all of that to set your precision the way you prefer. So for the points, our first one was -2, 3. Well, we can just type that in, and notice it will put it on there for us. For the next one, 4, 5, we can also plot points manually. So if you go up to the top menu and go to the middle, Tools, where it shows the circle and triangle, click on that. And under Basic Tools, your first row of options here, you can click on Point. And to do 4, 5, I can manually place that point by going to the right 4 and up 5. and placing my point. When I go back to my algebra view, it's labeled point B as 4, 5 for me. So that's pretty handy. For my last point, I can type that in, negative 2.4, negative 3.7, and it will plot my point for me. Then, as the slide had said, if I want to convert that to fraction form, I can start to type in the word fraction, and I'll see fraction text and then point, and I can type in C, and then it converts that for me. So now we can start graphing equations. Here are 4 different equations and an associated question to go along with each one that'll draw your attention to the neat tools on GeoGebra. So jot those down, and then we will try each one individually. Okay, starting with our first equation out of the 4 from the previous slides we were looking at, y equals negative x squared plus 5x minus 2. I've already typed that in and hit enter, and notice it gives me the graph. It also puts a corresponding label of a C with the graph. If I want to change that, I can click on the letter and I can go to the text box, and it will give me the show label option. Notice it's checked. I can undo that, and it takes the label off. So the question associated with that first equation was, can you figure out how to get rid of the label on the graph? And you just did that. For our next equation to graph, x squared minus y cubed equals 2. Notice I've already got it entered and graphed. Our question associated with this equation was, can you put a point on the graph that stays on the curve? Well, for this, you can use the Tools key at the top, go to Point, like we've used before, and after you click it, then click on the curve. Notice it plots a point A there. Now, if I go back to my algebra menu, I will see that same point A with its coordinates in my text box. Okay, for our next equation to graph, we have f of x equals x squared. So first let's graph that. And the associated question is, can you add sliders that control the translations of f? So for this, you can type in h There we go. Create slider. Sometimes it's a little glitchy. And then K, and you should get a create slider button also. Then you can type in f of x equals x minus h squared plus k. And the sliders can they give you the opportunity to do horizontal and vertical shifting. So you can either do it manually, or you can hit the play and it will cycle through. And there you go. Our last function to graph was the sine of x. So if we take a look at that graph, the associated question was, can you add a caption with the equation instead of the label? So notice our label f, you can barely see it, is right next to the curve. If you'd like to include a caption, you can go to the 3 dots in the same box where you typed in the function and go to Settings. And then this handy menu pops up. If you go to Show Label, make sure that box is checked. It gives you a drop-down box with different options. If you want to add a caption, you can do that. And then you can type it on the line above, and it will put whatever you type in with the function. Now we can move on to a little bit of advanced graphing. GeoGebra is great for intercepts and extrema. So we've got two problems here. First one, find the intercepts and extrema of the given function. Can you find them without the special points option? So go ahead and jot down that function. And then for part two, find where our f of x intersects g of x equals hyperbolic cosine of x. Okay, for intercepts and extrema, we have our first curve graphed. To find the y-intercept first, we'll go to the Tools option, and we're going to look for Intersect. Click Intersect, then click the curve, and then click the y-axis. And notice it puts a label A on the point. That is the y-intercept. So go back to your algebra menu, and you'll see that point A there, showing as the intersection of our f of x function, our y-axis, and then there's the coordinates. For roots, we will click on the Tools menu again, click on Roots, click on the curve, and it will label B and C for us. And if we go back to the algebra menu again, then your points B and C show up with the coordinates. For extremum, you can go to Tools again, and there's an extremum option. So click on that, and click on the curve. And notice it just changed our A to a D. If we go back to the algebra menu, then we'll see our extremum point again as 0, 3. Next, to find the intersection points for these two curves, once you have both functions entered, then we'll go back to our Tools menu and use the Intersect option again. After you click it, click on each curve once, and it will give you the points of intersection, A and B. And if we go back to our algebra, there they are again with the coordinates. GeoGebra is also great for graphing derivatives. So for what we have here, graph the function and its derivative. Go ahead and jot down your function. And then question 2, can you graph the function and a tangent line that moves on a slider? So we will do both of those. So we have our 2 sine x over x function graphed. Notice I did change the x coordinates. If you go to the gear settings option and go to settings, and I went to x-axis, and for unit I changed it to radians, to pi. So with this being graphed, now if we would like to graph the derivative function, you can just type in f prime, and it will give that to you and graph it for you. We can change the color on that to stand out just a little more. So we have our function graphed, its derivative graphed, and then our second question on that slide was, can you graph the function and a tangent line that moves on a slider? So for this, I'm going to go ahead and take off the derivative graph. Now we need to create a slider. I typed in A, and the Create Slider option usually pops up. So click on that. Then we're going to type in g of x equals f prime of A times x minus A plus f of A. And there's our tangent line. Our slider is going to allow us to move that tangent line, but we can also type in on the next line a f of a, and it'll give us that point of tangency, that point of contact. So I can hit play and watch my tangent line move. The students typically enjoy this. So you can let it go on its own, you can manually move it, and there you go. We can also work with integrals on GeoGebra. So here we've got graph the given function, use GeoGebra to illustrate the lower sum of the areas of the approximating rectangles. So just cosine 2x. And then we're going to graph and find the area between f of x and g of x equals x squared on the specified interval -1 to 1. So go ahead and jot those down and we'll give them a try. Beginning with our graph of cosine of 2x, we can see a pretty neat illustration of the sum of the areas of approximating rectangles. Specifically here we'll do an example with the lower sum. So once you've got your curve graphed, then we can enter n, and I'll do create slider. And I'm going to go to the 3-dot menu option here and go to settings. And for my slider, I'll choose the slider menu, and for minimum, for my n, I'm going to put 0. For maximum, I'll choose 100. And increment by 1. And that should do it for my settings. Next, I can start to type in exactly what I want to do, which is the lower sum. And the function will pop up for me. So it's asking for which function. I'll tell it f. Start value, I'll say from 0. And end value to 2 pi. And number of rectangles, we'll do n. So if we look at that, we can see the estimated area here. We can see our large rectangle here. But now we should, when I hit play, it should give me a nice illustration for how we fill in that area by increasing the number of rectangles. And we can pause it and do it manually to adjust so that they can see the additional area, the additional space with smaller rectangles, increase the number of rectangles, and starts to fill in that space. So pretty neat. So the second task for us on the last slide was to graph and find the area between f of x and g of x equal to x squared on the interval -1 to 1. So I have cosine 2x graphed and x squared graphed, excuse me. And now, if we want to find the area between them, we can start to type in integral. And notice we'll get the option integral between. Click on that one, and it's saying in between which two functions. Well, we'll tell it f and g. And then start value, -1, end value, 1. And it gives us the area and also a nice illustration of that area between. In summary, the sky is the limit. I hope this has sparked your interest in using GeoGebra, and I hope that you and your students enjoy it. Thank you.